Welcome students. So let's continue with the chapter metals and non-metals. And here in the last class we have studied about the reactions of metals with the oxygen and the reactions of metal with the water. So continuing that the reactions of metals, here we are going to see the next reaction of metals, which is the reaction of metals with the dilute acids. So here the general formula for the general chemical equation becomes metals, okay, emitters metals when reacted with dilute acids, they will form metal salt and hydrogen gas will be released out. So you have studied this reaction in your acid base and salt chapter. Okay, they are the reaction of acids, dilute acids with metal. You have studied there. So same reaction was there also. So here, let's take an example here. Okay, so the reaction of active metals such as sodium. So when active metals such as sodium are reacted with the dilute acids, there the formation of metal salt, that is sodium chloride, will take place here and hydrogen gas will be released out. Similarly, when potassium, which is also a highly reactive metal, when reacted with dilute sulfuric acid, there potassium sulfate will be formed out there with the release of hydrogen gas. Okay. Now, how magnesium reacts with dilute acid? So, magnesium can react with hydrochloric acid to form magnesium chloride with the release of hydrogen gas. Similarly, aluminium can also react with hydrochloric acid to form aluminium chloride with the release of hydrogen gas. Okay. Zinc can also react with sulfuric acid to form zinc sulfate, and releasing of hydrogen gas can be seen out. But the noble metals, the noble metals such as copper, gold, and silver. Okay, the noble metals such as copper, gold, and silver are not reacting with dilute acids. Okay, they are not reacting with dilute acids. Okay, they are not reacting with the dilute acid. So for reacting this type of substance, that is copper or gold or um, silver, we will be using aqua regia. Okay, we will be using aqua regia is a mixture of three parts of HCl with one part of HNO3, which is used for dissolving gold and other metals. Okay, aqua regia can dissolve any of the metals, and it is a mixture of the three part of HCl and one part of the nitric acid. Next is the chemical properties of the metal oxide. So metal oxides are basic oxides. Okay, metal oxides are the basic oxides because on reaction with water, such as if I am reacting sodium oxide with water, it will produce sodium hydroxide. Okay, on reacting magnesium oxide with water, it will produce magnesium hydroxide. Okay, so due to reaction of metal oxides like this, they are producing the alkalis there. Okay, they are producing the alkalis there when reacted with water. Due to this reason, we term the metal oxides as the alkali metals. Okay, sorry, we term the oxides of the metals as the basic oxides. Okay, similarly, when zinc oxide is reacted with aluminium oxides, and zinc oxides are generally insoluble in water. Okay, and aluminium oxides and zinc oxides are amphoteric in nature. We will see that aluminium oxide and the zinc oxides, they are having amphoteric nature. And an amphoteric substance is a substance which is having both the nature of acidic as well as the basic nature. Okay, so here when zinc oxide is reacted with a base such as sodium hydroxide, there a formation of salt will take place with water. Similarly, when zinc oxide is reacted with any acid, there also it will form a salt there, releasing water. So here in both the cases we can see that the zinc oxide is behaving both as an acid as well as an base on reacting either with an base or either with an acid. So this type of behavior can also be seen in the aluminium oxide also. Okay, so aluminium oxide and zinc oxides are known for their behavior of amphoteric nature. Okay, their behavior such as of the amphoteric nature. Next is the reaction of metals with other metal salts. Other metal salts. So here when metals are reacted with other metal salts, so metal 1 plus metal 2 salt is there. So here on reacting here, what we will see that the exchange of metal 1 with the metal 2 will occur out here, and the formation of metal 1 salt will be taken place here, and the metal 2 will be released out here. But a condition is that the metal 1 must be more reactive as comparison to that of the metal 2. Okay, in the reactivity series, the metal 1 must be present above the metal 2 there. Then only the metal 1 will displace the metal 2 in its salt solution. Okay, so here we can take an example for sodium reacting with zinc sulfate. So here sodium will displace zinc here to form sodium sulfate. Okay, from an aqueous solution only, this reaction will take place in the aqueous solution only to form sodium sulfate, and zinc will be released out. Similarly, magnesium can displace copper from its copper chloride salt solution to form magnesium chloride, that is MgCl2, plus copper metal will be released out. Okay, so the condition is that the particular metal which is reacting, okay, which is reacting here with the metal salt, they must be having higher reactivity and must be present above in the reactivity series than the other metal salt which has been reacted with them. So these were the reactions of the reaction of metals of with other metal salts. Here we will see that the noble metals such as copper, gold, and silver, they cannot displace. Okay, they cannot react or they cannot perform such reactions. Such reactions. Okay. Next is the reaction of metals and non-metals. Reaction of metals and non-metals. So as we know that the metals are having electropositive nature and the non-metals are having electronegative nature. So generally the metals and non-metals will react with each other to form ionic compounds. Okay. So here we will see that for example, if we are taking example for sodium, so sodium will release one electron to attain one positive charge to form a sodium cation here. Then chlorine will accept this one electron to form a chlorine anion here. Then this sodium cation and chlorine anion will react with each other to form NaCl. Okay. Similarly, calcium can release two electrons to attain 2 plus charge. And two fluorine atoms can accept these two electrons to form 2F minus charge. So here this calcium cation will react with the two fluorine anions here to form CaF2, calcium fluoride. Okay. Similarly, metals such as magnesium can release two electrons to attain a 2 plus charge, and oxygen, the non-metal such as oxygen, can accept these two electrons to form a anion here, oxygen anion. Then this magnesium cation will react with the oxygen anion to form magnesium oxide. So these are the reactions between the metals and non-metals here. Okay. So here we are going to so here now we are going to see the properties of the non-metals. Okay, properties of the non-metals. So for the properties of non-metal, chemical properties of non-metals. So except noble gases. Noble gases. Okay, sorry. First we have to give the heading there. So the heading will be reaction with oxygen. Reaction of non-metals with oxygen. Reaction of non-metals with oxygen. So here in the reaction of non-metals with oxygen, we are going to see that the non-metals, okay, I am writing the general chemical equation, so I am using the red color here. The non-metals will be reacting with oxygen to form non-metal oxides. Okay, non-metal oxides will be found out. So here an exception is there. The exception is that the noble gases noble gases will not react with oxygen to form oxides. Okay, they will not react with the oxygen to form the oxides. Okay, so we can take example here such as carbon. Okay, carbon means coal. Okay, here coal, when coal is been combusted, okay, coal is been combusted in the presence of air, then we will produce carbon dioxide gas. Okay, and heat will be released out here, which is showing that it is a exothermic process. Okay, similarly, when carbon is reacted or it is being heated in limited amount of oxygen, okay, in limited amount of oxygen, then carbon monoxide plus heat will be formed out. Okay, carbon monoxide and heat will be formed out here, which is a poisonous gas. It is more dangerous and more poisonous as comparison to that of the CO2. Next, sulfur reacts with oxygen to form sulfur dioxide. Okay. Hydrogen reacts with water to form, sorry, reacts with oxygen to form water. Okay. So these were the reaction of the metal oxides. Now let's see the properties of metal oxide, non-metal oxides. Okay. So the non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. So to prove this point, let's see some reactions. First reaction is the sodium oxide, sodium dioxide. Okay. When reacted with water, okay, sodium dioxide when reacted with water, it will form sulfurous acid. Sulfurous acid. Similarly, sodium trioxide when reacted with water, it will form sulfuric acid. It will form sulfuric acid. When carbon dioxide is reacted with water, it will form carbonic acid. Carbonic acid. So due to formation of this type of acids, when the non-metal oxides are reacted with water, hence they are termed as acidic oxides. Okay, while the metal oxides are termed as basic oxides, and the non-metal oxides are termed as acidic oxides due to their this nature. Now let's see the reaction of non-metals. Reaction of non-metals with chlorine. A non-metal generally reacts with the chlorine. So non-metals reacts with chlorine to form non-metal chlorides. Okay, they will reacting with the chlorine to form the non-metal chlorides. Non-metals plus chlorine will give non-metal chlorides. Okay, it will be producing non-metal chlorides. So here the reaction will be like this. When hydrogen is reacted with chlorine, it will produce hydrogen chloride, that is hydrochloric acid. When phosphorus is reacted with chlorine, it will produce phosphorus trichloride. Okay, phosphorus trichloride. Similarly, when carbon, which is also a non-metal, will be reacting with chlorine, it will be producing carbon tetrachloride. Okay, so these are the reactions of non-metals with the chlorines. They are forming non-metal chlorides. So these were the chemical reactions for metals and non-metals. Okay, now let's have a short discussion of some of the important questions. Okay, here, and let's solve these questions. So first question which I am asking here is, which of these metals exists as liquid at room temperature? And the options are A, sodium, B, magnesium, C, mercury, or D, gallium. Okay, So pause this video and try to answer by yourself. Now the answer will be mercury. Okay, the answer is mercury, because mercury is only metal, okay, only metal which is present as liquid in the normal room temperature. Next, the next question here is asking that which of the metals can be which of these metal can be easily cut with a knife, easily cut with a knife. So the option are zinc, aluminium, C, gold, or D, sodium. Try to answer this question also by pausing the video. The answer for this question is sodium. Okay, the answer for this question is sodium, because sodium is one of the soft metal which can be easily cut with a knife. Okay, so the next question here is which of these non-metal which of these non-metal is a good conductor of electricity. Good conductor of electricity. Okay, so the options here are A, iodine, B, diamond, C, mercury, and D, graphite. So try to answer this question by pausing the video. The answer for this question is graphite, D, graphite. Okay, mercury can't be the answer because it is a metal here. Diamond, it is one of the allotropes of carbon, which is a non-metal, but diamond is also an insulator, while the iodine, which is also a non-metal, it is also an insulator. Only the graphite is the allotrope of carbon, which is a non-metal, which can conduct electricity. Okay, which can conduct electricity due to presence of free electrons. Okay, due to presence of free electrons in its structure. Next question. What is the property of metal oxide? What is the property of metal oxide? Okay, so what is the property of metal oxide? So metal oxide's property is either it can be determined by atomic mass, or it is acidic, or it is neutral, or it is basic. So the answer here, try to answer this question by pausing the video. Now the answer for this question is it is having basic nature. The metal oxides are having basic nature. Okay, what is the property of non-metal oxides? The next question is what is the property of non-metal oxide? A, acidic, B, neutral, C, basic, D, amphoteric. So try to answer this question by pausing the video. The answer for this question is non-metal oxides are generally acidic in nature. Okay, because they produce acids when they are dissolved in water. Which of the following metal is burnt in air? Okay, which, the next question here is asking, which of the following formed when metal is burnt in air. Metal is burnt in air. Option A, hydroxide is formed. Option B, oxide is formed. Option C, hydride is formed. Or option D, carbonates are formed. So try to answer this question by pausing the video. The correct answer here is oxides. Okay, when metals are burnt in air, so metals reacts with the oxygen of the air to form metal oxides. Okay, they form the metal oxides. Next, which of the following metal, which of these metals reacts with cold water? Reacts with cold water. So here option A, calcium. Option B, copper. Option C, sodium. And option D, zinc. Okay, so try to answer this question by pausing the video. And the answer will be sodium. Because with cold water, only highly reactive metals reacts. Okay, only highly reactive metals react. So here the answer will be sodium. Zinc, copper and calcium will not react with the simple water. Okay, cold water. They will react with the either with steam or either with hot water. Which of the following metals, which of these metals do not react with water at any temperature? At any temperature. Option A, aluminium. Option B, silver. Option C, iron. Option D, zinc. So here, which of these metals do not react with water at any temperature? They are, try to answer this question by yourself. And the correct answer here it will be silver. Because silver being a noble metal, it is present below the hydrogen in the reactivity series. So it will be unable, the silver will be unable to displace the hydrogen from the water, and hence it will not be in reacting with the water. Okay. Next, what happens when iron reacts with copper sulfate solution? A, iron sulfate is formed. B, no reaction takes place. C, sulfuric acid is formed. D, none of these. Try to answer this question by yourself by pausing the video. So the answer for this question is that as iron is more reactive than copper and it is present above the copper in the reactivity series, so iron will naturally displace the copper from its salt solution to form iron sulfate. So the answer will be A. Next, which of these is which of these is the most reactive metal? Is the most reactive metal? A. Zinc. B. Sodium. C. Aluminium. D. Potassium. So the answer will be potassium. Okay, the answer will be potassium because potassium is more reactive as comparison to that of the sodium. It is the first metal in the reactivity series, and hence the potassium will be the most reactive metal. So for today, I am concluding the class here only. We have seen some of the MCQ questions also, and also we have studied about the reactions of metals and non-metals in this class. We will continue with the next topic of this chapter, that is the ionic compound, in the next class. So thank you for today. We will meet up in the next class.